Just with me. Search for is the that one. Has to be that one. Yes, that's one. So you're happy, Christian?
It's going to get better.
Yeah, in the projector we see very well. And anyways, it seems like we have time to. I didn't know they could hear me. That's kind of creepy. Right, so we could.
Okay, so can you please take your seats? So this is the core working group. I'm Carsten Bormann. This is Jaime Jimenez. The battery on this one is a bit low. So this is an IETF meeting. We are on a Monday, so I probably should dwell a little bit on this. There are some IPR rules that we're working under. So if you talk about technology and know about a patent claim affecting the technology, you have to tell us, or you can decide to just not talk about the technology. And yeah, the whole point is about making progress on drafts where we hope most people have read those. And the weird U's here are because Apple has destroyed the Keynote tool a little bit, so I had to convert the slides to PowerPoint and back to Keynote to be able to show them. So the blue sheets are going around, good. And we do have scribes. So those people who scribe, can they raise their hand? Take notes? Nobody takes notes? Matthias does, Alex does, Marco does. Okay, good. Thank you. So, yeah, I will have to substitute. From here. So the Note well applies. I think I already said what's on there. Let's talk about the agenda. We have two meetings, one now and one tomorrow at the same time. So today we will hover around working group last calls, either ones that have already been done or ones that will happen soon. And at the end, we will have a quick look at payment over CoAP. Is Adrian here? Thank you. And tomorrow we will have another one of those that are done with working group last call, another one that maybe is up to for working group last call, and then we will wander into less charted territory. Any comments on the agenda? Anything we should fix? Okay. So let's go right into the first item here, which is CoAP over TCP. Now this has been a never-ending story. We completed working group last call, I think in March or something like that. And we had a lot of brouhaha about the URI schemes. So we reached an agreement finally how to handle the URI scheme problem, and the current draft reflects that, and also should be clearing all ISG discusses. Can you have a quick look whether Milja cleared her? Oh, okay. Okay, so maybe somebody else can have a look whether the ISG discusses are gone on that draft. So AD approval, assuming we will be in the RFC editor queue soon. Oh, Milja hasn't cleared hers yet. Okay, maybe tomorrow. There's also a dependency on a small housekeeping document, hi-by WebSockets well known, because this document is assuming that the /.wellknown mechanism is defined for WebSockets, but it wasn't. So this document defines that, and we'll see where that housekeeping document goes. But for CORP over TCP itself, we are pretty much done. And we also spent a little bit of time on Saturday getting a few implementations together. There is a pretty well-cooked implementation now in libcoep. So that was a little bit our reference implementation on Saturday. And there are two implementations that are in the process of being created, one from Jim and one from me. And we managed to go to the place where we could do a get on /.wellknown/core, which, because of the fact that there are a few things mandatory you have to do before you can get over a TCP connection, is already quite some achievement. So Jim wrote up the issues that we found there. There is one example that isn't quite right. I think a hyphen is missing on an option name. I think the only place where we probably want to think about it a little bit is what does it mean to send a request after you have sent a release. In CORP over TCP, we have an explicit release mechanism. So one side can shut down the connection without disrupting things that the other side is trying to do at this point in time. And we didn't really say very much about what it means to have sent that release. And we might be more explicit about the idea that after having sent release, you are not supposed to continue to use the connection as it was. So that's maybe something that the authors took for granted, that is kind of obvious, but it could be made explicit. And also the text could be made a little bit clearer on the situation where you do a ping pong and you have a custody option in the ping, but the other side doesn't want to do a custody option in the return, and there is currently no language that discusses this case. And the point here is, of course, that the delay language that is there for the case where the custody option is present doesn't apply to this case. So this is the level of issues that we have had at the hackathon. We probably could address this in a -11. Of course, we are still waiting for the discussers to clear, and Alexei has to do the evaluation whether we did handle the comments right. So maybe there are a few more small editorial things, but apart from that, I think we are done with it. And at the start of this segment, I should have said that I'm changing hats because I'm not saying this as a chair, because I'm a co-author on this document. Sorry for not pointing this out. So whether this, Jaime is the working group chair on this side. Okay, any questions on discussion items on CORP over TCP?
Tim Carey, Nokia. I just got a question on this. I'm trying to get an understanding of just timeframes, right? Are we talking about this? Do we think that this is going to go into the editor's queue this year?
Yes.
Okay.
So there is an interesting date that we should be working to, which is the Consumer Electronics Show in Las Vegas. And by that time, it should be in the RFC editor queue, or we get some problems. So that's really the ultimate deadline, and we want to have it in the queue before that.
And that's what, February, right? Or when?
No, it's January.
January.
It's only in January.
Okay. All right. Thanks.
So it should be under the Christmas tree. Okay. Next item, Coco. Can you use this microphone and do next slide until I have fixed the.
Okay, sure. Okay, good afternoon, everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled CoAP Simple Congestion Control Advanced, also known as COCO. Next, please. So first of all, let's take a look at the status of the document. So the last revision is 02, and the motivation for this last version is that a few months ago, Jaime sent a heads up on 01 before initiating a working group last call. So the heads up was sent to the core and TCPM working groups and also to the ICC research group. So after that, we received 2 reviews, one by, sorry? Oh, you're right.
Yeah, just continue talking.
Okay, yeah, so version 2, so the last update of the draft is actually aimed at addressing the comments that we received in those couple of reviews. And so, yeah, so also we expect 02 to be the version that would possibly be intended for working group last call. So let's go through the updates in this last revision. So we have one technical update, which is that the impact of strong and weak estimators is now tunable. That's the impact of these 2 estimators on the computation of the RTO as a result. And the idea is that in the previous version of the document, we used some fixed constant weights for the contribution of the weak and strong estimators. As you can see, those weights were 0.25 and 0.5. However, in the new revision, we have tunable parameters for those weights, which are the ones highlighted in red, W weak and W strong, which, by the way, have 0.25 and 0.5 as default values. Next, please. So we also have quite a number of editorial updates. Actually, most of the work in this last revision has been editorial. So first of all, we have extended the abstract in order to explicitly indicate that the core of this specification is an RTO algorithm. Then in section 1, now we have a proper introduction, whereas in the previous version, the section was almost empty. Then section 3 describes the area of applicability of the document. And now we explain, we have added that the algorithm defined being adaptive is actually intended for a wide range of network conditions in terms of different aspects, such as network topology, traffic load, different link technologies, and so on. So related with that, in section 4, which focuses on RTO estimation, now we explain that we expect this algorithm to run in different conditions, and we expect a wide spectrum of RTTs, ranging from few orders of magnitude below the default RTO estimate in COAP, which is between 2 and 3 seconds, and greater values than that. Then also in the same section, we have added some content to the discussion we had on RTT variability. So previously we explained that in COAP we have application processing times that contribute to the COAP RTT, which in addition may be variable with different distributions. And we explained in version 01 that this is something that doesn't happen in TCP. However, now we have also added that if TCP is using delayed acknowledgements, there's also some contribution in that case to the RTT, which also may be variable, with additional delays that may be up to 200 milliseconds typically, or in theory up to 500 milliseconds. Next, please. Then another update is in the subsection that makes a discussion when we describe the measured RTO estimate, that's 4.2.2. And in order to better motivate the need for the weak estimator, which is quite unusual in the IETF, we now explicitly explain that the weak estimator allows to update the RTO estimator when RTTs are mostly weak. So recall that weak RTTs are those for which the sender has run into retransmissions. So this may happen, for example, when we have really lossy links, or when there's some congestion event that induces losses as well. And we also explained that in the latter, if losses are due to congestion, then the weak estimator allows to update the RTO, actually increase the RTO as well, and this helps avoiding spurious timeouts, reducing the rate of retries, and decreasing congestion. So we have also added references to the base COAP specification. This is intended for readers that might not be so familiar with COAP, and we have provided pointers to specific sections and also to specific parameters in several cases. And on the other hand, we have also extended section 7, which provides the security considerations, and we now explain that an attacker that manages to prevent packet delivery will lead to an RTO increase, which may lead to a performance decrease. However, well, this attack is not specific for COCO or even for COAP, but anyway, this might be mitigated by means of network access control. And if the attack is performed by means of radio jamming, we argue that recovery from that situation can happen in reasonable time when COCO is used, because the weak estimator increases the chances of obtaining RTT samples even when there may be a large amount of losses, leading to almost only allowing to get weak RTTs. Next, please. Finally, we have also quite a number of updates regarding appendices. So first of all, the old appendix, which was entitled Aggregate Congestion Control, has been removed from the document. This was suggested by the two reviewers mentioned at the beginning of the presentation, and this also matches the actual intention of the authors. So this has been removed. And however, we have added 3 new appendices. Appendices B, C, and D. The first one, Appendix B, provides pseudocode on how the RTO estimator update works, also on how the RTO aging mechanism works, and also for the variable back-off factor. On another appendix, we have added some examples where we provide numbers on the calculations for the weak RTTs, for the variable back-off factor, for aging, and we also provide some explanations which try to clarify a little bit the properties of these mechanisms. And finally, we have added the last appendix, which provides some analysis on which may be the difference of the values, the difference between the values with the strong and the weak estimator. So, well, so that's all for this presentation. Any comments or questions?
Hi, this is Hannes. Thanks for the update. It was really useful. One question that wasn't answered from my review is when, as a developer, if I care about, so the reason why I would want to take your document into consideration is because I don't want to have this stop and wait behavior that co-op over TCP provides me with the end start equal to 1. So with the advanced congestion control mechanism, I can actually change that and have a value higher than 1. Is that correct?
No. So, Carsten Bormann, the congestion control doesn't take away the stop and wait behavior. So you still have lockstep, send a request, get a response, send a request, get a response.
But can I now have more than one outstanding request? Or outstanding response? No?
No.
No, this document doesn't modify end start, for example. So what this document does is, instead of having the static setting for the RTO in the base co-op, which is between 2 and 3 seconds, now we compute the RTO on the basis of RTT samples.
Okay, so that leads to my real question is, I think it would be nice to indicate on at what point a developer should actually move away from co-op plus that type of extension to over UDP to a model that co-op over TCP. Like co-op over TCP was motivated by a firewall traversal, but there may be other motivations as well that relate to the congestion control or specifically to this behavior of sending multiple requests, which is sometimes also annoying. Does that make sense what I'm saying?
Actually, you have written the text for that. So the introduction for co-op over TCP now provides information to this question.
It provides background for the co-op over TCP, but it doesn't provide the information on at what point should I consider not going for this document, but then for something more. Like, I don't understand what the complexity difference is. Neither the LBIG document on TCP implementation guidance, nor this document, nor any other document provides me that type of judgment. I think the complexity and so complexity versus the benefits aren't too obvious to me, and maybe not to developers either. Maybe it's obvious to you, but
yeah. So I don't remember the details, but I think we put some text in the COCO draft that discusses what the incremental complexity is with respect to the base congestion control.
But this is the COCO draft.
Yes.
Yeah, and I read the COCO draft and it wasn't in there. But maybe it got stripped out along the way.
Let's check that.
Okay.
And the next question is, when do you actually go to TCP, which is a bigger step? And that of course depends on the complexity that your specific platform needs to run TCP. It also depends on your application, whether that actually benefits from an aggressive transport protocol. So in some sensor environments, it's actually a benefit to not have an aggressive transport protocol.
Yeah, fully understand that, but the LBIG TCP guidance document gives me the impression that TCP is also highly tunable, and there's a lower bar and there's a higher bar, and so I don't see where the overlap is between what is going on here to what is going on in the LBIG group with terms of usage of a transport protocol. And I think there could be some additional clarification offered, specifically if you're not like working full-time in the transport area. And maybe you have that information written down somewhere already. It would be good to add it.
We happen to have the author of the LBIG TCP document very close. So maybe that's actually a useful thing to add there.
Yeah, maybe it needs to be added there. I don't know what the best place is, but it would be nice to have the information somewhere.
Yeah, sounds good. Now, what we don't have is numbers where we can say, by the way, implementing TCP takes you this amount of ROM space and so on. Oh, good. So we already have that.
Somewhat. There's only, at the moment in the LWIC document, we have those numbers, but however, only for a subset of the implementations we are considering. So let's hope we can complete the information at some point.
So the advice that should be in the COCO document is that if you have space to keep 2 or 3 variables per peer, plus evaluate 2 or 3 formulas for every packet you send per peer, then you should do COCO and not the basic congestion control. Okay, I hope the note takers have that, and we will consider that. Now, so the next step, of course, is doing the working group last call. Jaime has to decide when to do that. And the idea is to make sure that this working group last call is done in a way that the transport working groups that have indicated interest, and also the congestion control research group is in the loop of that working group last call. And I think Alexei has something to say about how he then wants to handle the ISG processing.
You mean my idea of asking another AD? Yeah. I tentatively asked Mirya to, as a person more familiar with this stuff, to be the responsible AD, and she did ask recently what the status of the document. It was expired. I said, well, it will be renewed, and so I'll talk to her again.
Thank you. Okay, so barring any other comments, I think we should check the conversation we just had with Hannes and then go for working group last call. Okay, so next one is resource directory, and we have a remote presenter for that. You just have to press the red button.
Hello, do you hear me?
Yes, we do.
Thank you. My name is Christian Amses, and I'd like to present the current status of the resource directory document and the associated resource directory DNSSD linking parts. I'll go through the recent changes briefly, and use them as a setup to show where we are with the document, and to ask some questions about how we can proceed there. There will be a part about DNSSD2, which will be after the actual RD text. Slide, please. One change we did since version 11 was to introduce a number of statements about what we think the RD should do, which basically amounts to storing links with the same semantics they have when they are retrieved from well-known core documents, and allow clients to fetch those links and query that information with the same mechanisms they use when they are doing regular multicast or well-known core-based discovery. An RD can also come into play when multicast is unavailable, or when there are other reasons why you don't want to get that information directly from the node. DNSSD is not directly here in the motivation, because I'll show later that we can do everything we need for exporting to DNSSD from what an RD can do if it is designed without particular consideration for RD DNSSD. Next slide, please. So what is in a resource directory? And we've flashed out how this looks textually now as well. The RD contains links, and the top line shows how they look like in a well-known core file. They have a link target at the left, which is evaluated to a full URI. They have a link source, which is usually the well-known core document or the device itself, and in most common cases it is implied. and has a relation or some other link attributes and attributes that describe the target. So for example, resource type. We transfer, we take those links up in the resource directory and express and replicate them semantically, which means that the serialization might look a little different. For example, the anchor, as in the bottom line, needs to be explicitly stated because the document comes from somewhere where this is not obvious. But some things like the rel relation, like the rel equals hosts, can still be implied by default.
So Christian, let me quickly mention, because the projector is not showing great here very well. This is gray here, and so these are default values of the target attributes. So the actual well-known core entry would just say this part here, and this is defaulted. So the link relation hosts and the empty anchor, those are the default values. And the point that Christian is trying to make is that this can stay at its default value, but the anchor value actually has to change, because in this case, it's the well-known core environment that provides, so it's the device itself. But in this case, it's the resource directory, so this has to provide the other end of the link, the place where the link emanates from. Go ahead.
Thank you, Carsten. If you go to the next slide, please. There are some other entities in the resource directory, which is endpoints and groups. Endpoints is mainly what we are using to manage that a particular device registered there and can have some additional properties that are available for querying. And groups, which are aggregates of endpoints that typically share a multicast address. Next slide, please. All these entities can be used in queries across the resource directory. So you can look for, as in the first example, look for groups which contain a particular node. And then you get a link to that group resource to the place where the group is registered with some additional data about the group, like what is its multicast address, what is its group name, is it in a particular domain? You can, so this is in this image, this uses information, this queries down the stack. You can also query up, as in the next example, where we are looking for all endpoints that are in the rooms group. So this again gives us a link to one registration resource, which is not particularly useful as a link to a query, but contains additional information in the metadata. For example, this has an endpoint type, or where is this registered from? And most importantly, it contains the links, which can be queried not only by querying their attributes. So for example, you could have a lookup/res query RT is temp and get all temperature resources, but you can also query all resources that reside on, say, endpoints that are wall mounted, as in this example. Next slide, please. We did some more changes to, I won't go through every single of them, but some are particularly noteworthy. We've added an information model that kind of provides the whole setup. We, as I've shown on the first slides, we've nailed down how the resolution of URIs works. So what does need to be resolved when? How are relative references evaluated? And we removed sections about how those registrations can be changed, because we don't have suitable content formats for that yet. So we can't specify how this works anyway, and we prefer to specify how the general thing works. And if and when a content format gets along that allows simple modification or observation of collections of links, which everything in the resource directory basically is, then this can be added to the resource directory without further changes on the information model and on the lookup. Next slide, please. So what are the next steps? We've published a version 12 document about a few weeks ago. Next slide, please. We do have some changes we know about that we'd like to have in a version 13 document. For example, registering a multicast address and fixing something about that you can actually go up and down in the image I've shown before in the queries. But there are also, slide please, some open questions, especially about how, next slide please, especially about whether an endpoint registration can be included in a group even if it is not registered on the same resource directory, which is really kind of doing the icing because resource directory is not originally specified to be federatable, but it looks like it can be without doing much on the specification side. And we'd also like to have some idea of how this specification or how this interface can evolve without breaking older implementations. We invite you to join us on the issue tracker. All the those open issues and also the pending ones are described there. And it would be very good to have input from the working group on those. Next slide, please. We've received comprehensive reviews from Jim Schad and Hannes about the 11 document. Thanks for that. But I think given that we'd like to go for working group last call soon, it would be good to have more reviews and also to get input from people who are actually implementing the resource directory.
So just to expound on that, now is a good time to implement this stuff because we have really cleaned up the document a lot. And at least for me as a co-author, the situation has started that I understand what the resource directory is about and how it works. So I hope that implementers can now be in the same situation. And of course, there are partial implementations in various environments. For instance, lightweight M2M uses the resource directory, but only a certain subset. And doing the whole thing now seems possible. And it would be nice to get more feedback. Hannes.
I have a question on the slide, on the changes slide. There was one note about removed all methods that modify links in existing registration. And I was wondering whether this also means that if I do an initial registration, if I do then a re-registration, would that prevent me from changing the links there, or did I misread this?
You can do a link registration and re-registration, and this is currently the only way to do it. The re-registration is semantically almost equivalent to dropping your registration and registering anew, and this is what you can do even without explicitly dropping your registration. So you can just post to the directory resource again as you would do, for example, after a reboot, when you've forgotten that you're registered, and then the RD will accept that registration and now have an updated set of links.
And this re-registration, would that require me to resend everything again with the modified version? So if I want to remove one link, would I have to resend everything, or would I indicate at least remove that one thing?
Yes, you will have to resend everything in that re-registration because we don't have the content formats yet that would allow you to say this is a patch on that linked list, and please remove that particular link.
Okay, so that's maybe something that we may need to look into a little bit, because in lightweight M2M, at least the registration interface, we were hoping that we don't have to send everything again when we do a re-registration when the lifetime expires.
Oh no, you don't. When the lifetime expires, you can always keep your registration alive. So you can just post to the registration resource you've obtained, but it will need to be an empty post and it can't change the links. It can't change the links, no. But you can register anew with a new set of links.
So the important observation here is that right now we don't have a media type to patch a registration. So we can wholesale replace it.
Yeah.
we can refresh the registration,
Yeah.
but we cannot say change the third star on the top by a little bit.
But I was hoping that in earlier versions of the document that Michael presented, at that time, batch wasn't available. So my hope was that once the batch was available, and there were actually two different versions in there, with and without batch, that we would, once batch is available, we would actually switch over to batch and allow that batch to be used also for the registration interface. That sounded like obvious to me, but maybe it's not.
So the decision was to define that patch media type in a separate document, because we don't have to hold up this for defining that media type.
Okay, I missed that.
And we had a pretty interesting discussion at the OCF meeting on Friday how to do that, because the current merge patch document is geared up for having maps of things, and you essentially replace things in there by giving their keys. But those link sets are not maps, they are arrays. So we need a variation of merge patch that grabs into an array, finds an element of the array based on one of the keys in the map that is the element of the, and replaces that. And we have to write that up.
That must have been a discussion after the OCF meeting also.
It was at the lunch.
Okay.
Jim Schott. I vaguely thought I actually saw that the map stuff existed, but I wasn't paying that much attention at the time because I was having a hard time figuring out how to do patch. But that's not actually why I stood up here. One of the things that really worries me, and I'm not too sure I want to see the RD actually progress until we figure out how it's supposed to interact with the new URL schemes, so that because I'm not too sure if you want to, if something is reachable by multiple schemes, I don't know if that means you end up with multiple endpoints and so forth, and what that means in terms of anchors.
If you're registering, the current idea is that if you're registering with multiple URL schemes, you will still have only one registration, and the pending protocol negotiation document will describe how you add your alternative transports and how you can query them in the resource lookup, so that you will finally get a resolved link based on your preferred transport when you're querying the resource directory.
Is that going to, am I going to have to heavily modify my resource directory implementation when that gets done, or should it work?
You will need some modification because you will need to interpret the information that is now provided in whatever attributes that come along, but the changes should be very minor.
This is Dave Faber. What's the current state of the protocol negotiation document? In other words, how close is it to being done? Because what I hear Jim saying is that you have to treat them together, and that if you haven't reviewed them both at the same time, then you're skeptical that this one can progress before that one, right? I think that's what you're saying, Jim. And so the real question is the other one also ready for working request call? I hear Jim arguing to put them through at the same time. I'm not arguing for or against, but that's how I understand Jim's comment.
Yeah, so we know how OCF does this. So we have an existence proof that it can be done, but it still has to be done. So maybe we can copy as much as possible from the OCF solution there. That would be my personal preference. But that discussion needs to be had, yes. And I take from the input that that's really a blocking point for finishing RD, because we need to understand that. Now, there are two kinds of alternative transport situations. There are situations where you have transports that are mostly equivalent in most of the technical parameters. So one may go through a firewall, the other one may not, but once it works, it doesn't really make a big difference which one you use. And we have other situations where we, for instance, combine UDP access with SMS access. That's a very different situation. And I think we have to make sure that we actually address both cases. Okay, the mic line is empty. So maybe I go back to you, to your reviews slide.
And yeah, I think we could just proceed to the next slide, which starts the part about RD DNSSD.
Before we do that, a quick question: who has an implementation of a resource directory at this point? Pardon me? Yes, I mean it's partial, but it does something. So who has such an implementation? Kind of. So we have two implementations that do something in the same space, and California does have one. Jim has one. I have an old one from a student that probably needs to be fixed.
And I have a current one.
And Christian has a current one. So, yeah, so what I get from this is that we have enough substance here that we actually could start doing some interrupt testing. We didn't get this into place in time for this hackathon, but we might want to use the time between now and the next IETF to actually do a little bit of virtual interrupt testing between our implementations. So how we do that, we have to find out, but I think it would be a good thing to start with that now. Okay, Christian, DNSSD.
Yes. So I promised that we would that I'd show that DNSSD works from the RD. What export to DNSSD unconditional needs is some support from the origin server, so from the endpoint that is providing the resources, to say that it wants to be exported, and to provide instance names because they can't be derived from anything that is present in the resource directory otherwise. The current document that should be published about today describes this as happening from a resource directory, but actually it can equivalently work from the well-known core data as well. So while an exporting agent would typically piggyback on an RD, it could just as well do multicast discovery and export whatever it finds from there to DNSSD. How this works has not really changed since DNSSD was a part of the resource directory. I'm showing next slide, please. I'm showing here on the top a typical example of what a resource lookup could look like in the RD, and the bottom half represents that information in DNSSD. So next slide, please. The information gets moved around a bit, but what is in the DNSSD record is DNSSD type that is derived from the resource type. It is registered in the domain, which is shown in green. It uses the instance from the link format document as an instance name. And if there is a subtype to the resource type, that can also be exported to DNSSD, which is the purple part. This is the first half of the DNSSD content, and the second is the mapping to the actual address, which happens in a server and a text record to form the complete URL again. If the link is not formed from a DNS name as the authority, which is shown in red here, it could also be derived from data in the resource directory, but then again could be derived in any other way just as well, because there just needs to be an A or quad A record for the thing that the server record points to. Next slide, please.
Before we go there, another question?
Dave Taylor. So question on the part in blue, which is the SDO. And so this example uses an RT value with only one dot in it. There exists plenty of RT values that are registered with IANA that have 2 or even 3 dots in them. So the question is, when going to DNS, is there any problem because you had the underscore SDO?
Mm-hmm.
Is there a problem if that has dots in the middle of it?
Fun thing is, it isn't, because the way DNSSD works is it doesn't work on the serialization of the DNS record, which usually uses a dot to separate the segments, but it works on the actual DNS messages, which have fields that are not dot delimited. So there can be a dot, for example, in the instance name or the resource type.
So it sounds like, no, there's not a problem. It can work when the
Yes.
when multiple dots in the RT value is what I'm hearing. Is that right?
Yes.
Sounds brittle to me.
Personally, I don't like it very much, but given that there already can be dots in the instance names, and implementations largely support that. But there is, and this now brings us to the next slide, still the open question of how those things should be mapped exactly, because the issue we are having here is that for resource types, there is a registry. So you could register the SDO dot anything resource type, and there is a registry for DNS SD service types, which is not the same registry and which is not coordinated, and most entries or many entries will not need to be in both. So there.
Question, Christian.
Yeah.
So I realize I may have phrased my question slightly differently than I should have, but you probably answered the question I was asking. What I should have said was there exist RT values with multiple dots, and here you split it into a SDO plus a temp piece. And I should have asked, how do you know which dot to split out?
Yes. Boils down to the same thing. We have an open issue about that. One proposal is to say that, can you go to the previous slide, please? If a resource type is unknown to the DNSSD exporter, it should not be split by any dot, but it should be exported as type coop UDP with the whole resource type as a subtype. And particular SDOs or whoever registers a resource type can also register a DNSSD type and their subtypes, and along with those registrations provide a pattern in which by which those resource types can be converted to DNSSD types. So then the DNSSD converter needs to be aware that this RT scheme is handled like this in DNSSD, but this information needs to come from somewhere, and providing a simple pattern with a registration would be one way of handling that.
So Dave nodded several times during
Thank
what you said. Okay, so I'm going back to the question slide.
Yeah, questions is exactly the slide where we are now.
So if we're expecting a server to know the instance name, and we're trying to have the exporter make assumptions on how to derive the service name, why wouldn't we just expect the server to be able to derive or state what the service name should be, since we already expected to state what the instance name would be?
That's a viable suggestion and would be an alternative to having that registry. I figured this might look like having not an exp, but an exp DNS with the particular service name. Could be done, I think, and might be a better option.
So the objective when this was designed was to have the exp and ins attributes be kind of generic. So the node that exports these attributes does not really have to think in DNS-SD terms. There might be other lookup schemes that are in use, but maybe that generality is not needed. So I think that's a good discussion to have.
Yeah, because it sounds like, your resource types, particularly as they start getting, hierarchical, SDO dot whatever, your exporters might not know that, but your server should, particularly if they have to know the instance name, right?
Yeah, there is a strong argument that the evolution of the various parts of the system can go on in parallel. So if the device already knows about a resource type that the exporter doesn't know about, that should work. The device shouldn't be forced into a weird situation there. So I think that's a good argument. Okay. Nobody else is running to the microphone. So let me just, as an author, comment on the pace in which this document has gone on. For a long time, we have had essentially a little bit of progress at each IETF, but nothing in between. If you look at the commits that are on the GitHub repository now, it really has taken off, and we have significant progress. And we want to keep up that pace and finish this work. So again, comments like those from Tim here, that's really useful input, and that would be good if you could provide us with that input. So timeline, to preempt a question that Tim is probably going to have, not under the Christmas tree, but we shouldn't go on with this much longer than the London IETF, I think. Okay.
Thank you.
Thank you, Christian. You on the in-room screen, you have this really weird look because your glasses reflect the light, and you have these blue glowing eyes. That's funny. Presentation from outer space. Okay, thank you, Christian. So we're ahead of schedule, and I'm sure the comic people will squander that.
Thanks. And now for a presentation down to earth, let's say. That will take a little bit more time. So we are going to be talking about COMI. So I'm going to be giving a couple of updates since the last time. On a very macro level, you can see the main drafts that are part of this package. Here it's a little bit offset. So basically, here we have the three main draft documents that are the Yang to CBOR mapping, the SID draft, and COMI itself. So we had some actions from the last time, which were review the drafts, perform interop, deploy the SID registry, like down to straight to the point. So on the update and on the review of the different drafts, the Yang to CBOR draft hasn't moved, because one of the things that we said is these three drafts, basically they're moving in as a package, right? The moment that we have some interop and that we see that everything is working well, then we do the working group last call for all the three of them. So basically here we are ready for working group last call since IETF 97, which was not 3 years ago, unfortunately, or fortunately. Then we have the core SID that is stable for 2 IETFs now, and the COMI, which is the one that is mostly evolving for the moment. So, and then there are some new drafts that have been added that allow the whole system to be working very nicely. But these are like just some extras. So where are we? And this is the point that we actually start talking, this one works. Okay, thanks. This way I'm not going to be able to, I don't need to turn around always. So we have existing implementations, as I said. Since the last time we had some, and right now we are really improving our implementations. So we have two implementations that are proprietary implementations. One is Golang, one is C. And we have two partial implementations that we had some knowledge from the last IETF. And one of the goals was for this IETF to have an interop with at least two implementations of them, and to have a hackathon, in order to produce an open source implementation, or at least put the basis of an open source implementation, because it always goes through the open source. So we needed to scale back a little bit on our initial expectations, because most of the key people that were not able to come here to Singapore. And so we needed to scale back on this, but we did our best. So I'm here to present what is our best at this point. Well, after several exchanges and many, many discussions, we actually managed to do a virtual interop over the internet between two implementations. So the first point here is that one of the implementations actually manages to run a full COMI with a subset of the functions that are fetch, patch, and post for RPCs running on IPv6. The other one is full, but can interoperate with itself. So it's not much enough interoperability between two different implementations. So the point that we really did was to say, okay, we need to have at least these implementations to be able to show that they are running. So we have fetch, which is the basic of everything, where you can go and can really retrieve information from the server. So you're the client and you can retrieve information from the server. So the type of request that was, so we needed to have a use case, a test case. So we was using the module IETF system. And more specifically, we were just trying to get the system date, right? What is the current time? So we have the SID file that is generated for this with the SID allocation that allows you to actually build the whole COMI system up. And through this, these are the first results that we have. So we are able to, okay, maybe I can do this. So we are able to fetch single values, fetch a container, fetch two values in one single request that are two separate values. Whenever we tried, so we found some issues with some of the implementation. So we are now, it's like minor bugs, we are fixing this. And with this, we actually managed to validate the Yang to CBOR string mapping, derived types, container representations, and we have also validated the delta encoding and having a delta URI, like delta compared to the URI that is given in the fetch request. So this is a first result of a first interoperability, like on a basic use case that is out there from two implementations, independent implementations. And that is pretty good, given the time that we had to, to do this since the last IETF. We are quite happy about this. Of course, our goal is to go and to do much more until the next IETF. Next point, so yeah, but before I go to this, I would like to share some of the lessons learned through this interop. So the first thing is that IETF system may not be the easiest module to use as an interoperability basis. And one of the things is basically we want to test everything. We want to say, okay, this is an integer, this is a string, this is a float, this is everything. We want to be able to have like a basics, all the things that can be present in a Yang module. We want to be able to go there and do like fetches and patches and have all these nice stuff that we can have with them and gets and puts. So and just so that we have like these unitary tests and that we can do one against the other. So one of the things that we are starting to do, and this is starting again right now, so we are ramping up. We had, so to give you a short idea of the timeline that we had. Until the past IETF, we had bi-weekly meetings, so we were managed to advance pretty well. Since the last IETF to this one, it was like the summer and all these kind of different issues that happened, so we were less, we didn't manage to have these virtual meetings, and right now we are restarting them again. So we are restarting 2 weeks from now in order to define this interoperability suite and to be able to have it ready for the hackathon in IETF 101. So that's the first issue that we would like to address, is to have these basic YANG modules in order to test this functionality on the protocol level. And here, this is a question also to have maybe NetMod have already established such a baseline YANG modules for testing. I'm not aware, but no, I see Eric saying no, so no. So maybe this is something that we could contribute also to the NetMod community. So that's the first point. The second point is that, you know, these famous Delta encodings that are super efficient and are really, really nice, and we really do like them. And one of the things is that, and with Andy, he was also saying this in the past, it could be a little bit tedious when we are trying to debug complex requests and complex queries that have different, you know, you have several subtrees, and you could get a little bit lost in case you're just only watching the payload. And of course, with the right tools, this is not a problem. But we are not there yet, having the full tool set that we have all the, you know, the debuggers that keep everything in place. So one of the things is that we are really would like to propose is to have this option in the server and or the client that can say, okay, well, you know, I would like to disable for this session the Delta encodings, and then we go and tag the SIDs with CBOR tag 39 that has been allocated. It's an identifier, and just to indicate, hey, this is the SID. It is not the Delta SID. It is directly the SID. And the simplest thing in this is that, you know, in your code, you just need to whenever the code is parsing it, you know, they don't need to do anything special. They are just doing delta, delta, delta. Oh, that's not a delta, so I'll just take the value as it is, and I continue. So it is a pretty straightforward solution. It helps debugging, and you know, you run your server and account in debug environment, you debug, and then whenever you decide that it's good, well, you disable it.
Carsten, my reaction to this is you can do that, but don't tell anyone. I mean, you really should fix up your tools to handle this. It's not that hard. And I think doing this tag 39 hack is about the same amount of work as fixing up those tools. So why not just fix up those tools and do the right thing all the time?
So I think one of the things is good when we want to have an interop is to, I mean, we can say, okay, we're going to do this dirty hack, but if you can have it on your interop, that would be really cool. So please, everyone, hack your code, and then, you know, just de-hack it. So yeah, somehow I agree with this, but it is a very neat solution. I don't see any any problem with it, like a long-term problem that could appear. But
the long-term problem is that this stuff is going to appear in production systems. Don't do that.
Okay, even if it appears in production system, it is going to waste, let's say, bandwidth for people.
No, it's going to jeopardize interoperability because I will never implement it. I mean, it's way too easy to fix the tools to show the right values. I mean, you don't really want to see the SIDs anyway. You want to see the actual identifiers. So you need to have a tool to do that anyway. So I think that's yeah. You're trying to run a marathon on crutches, and that's not going to work very well. Hannes probably agrees with me.
So Peter?
Peter van der Stok, I won't be very original. I support Carsten's remark fully. I don't think you should add complexity to reduce complexity. Sorry.
Okay. So that's a Point taken. We'll improve the tools. So another point that we had from this first interop was that actually we have this minimal set that is pretty straightforward and that allows us to have the full functionality of COMI. And one of the points that we'd like to just state there is that it is possible to have COMI minimal plus COMI extended. And let's say COMI minimal is fetch, patch, and post for the RPCs. And then we can have a very simplified document. And you have a second document or like two sections where the second section builds upon on the first one. And then we say, okay, you know, if you want to do get, put, post, and all these nice operations, then, you know, this gets transferred to patch this or fetch this. So this way we can like really go with COMI minimal, COMI extended, and, you know, we basically, it boils down to this, like we have these implementations. And we will be very happy to have other people having different implementations, but until we have, this is the only thing that we'll be able to interop. So that's about the implementation part and the lessons taken. Now on the hackathon. Well, on the hackathon we did start an implementation. So we started with a specific module in mind because we wanted to have a specific use case. So in this case, we started with the SHIC context compression. So we expressed SHIC in Yang, and then we started, you know, like building the whole system around it. I can declare partial success. So yay, we started it. We have the Yang module and everything is working. And then a partial failure because actually I made some maybe not the best choices in the use of the in the choice of the Python tools that were out there, and so we reached to some point where we understood that the choices of the basic libraries that we chose for Yang actually makes it super difficult to make the CBOR encoding well. So I need to go back a step. This was after discussion with the netmod team, and basically rebase the development of this part with YDK, which is the Yang development kit, which based on your Yang file produces Python code. So this is the only thing that needs to be done. So I was really hoping that we'll be able today to come and say, hey, we have this working baseline implementation and it's, you know, it's interops with these other parts. But I think that we should like step back a little bit and prepare for the official hackathon that will take place at the IETF 101, and where most of the people that are actually quite active and who are working a lot at on COMI will be there. So then we'll be really around the table and really be able to advance with this. So that's about the hackathon. And so, as I said, next steps, bi-weekly meetings from now on that will ensure that we have the full interop in London with the fetch and patch. So something like, as I said, the COMI minimal, and have the hackathon also and prepare the open source implementation from there on. So these are the next steps. And on the Yang to CBOR document, I get the feeling that we will not be introducing the option 39. It looks so cool. It solved some problems and the option was there. So, okay, so that one is done. And on the COMI document, what we propose to do, so this is like an option, and this is something I would like to hear the working group, if you have any opinion on this. Would you like to see COMI minimal and COMI extended? If this will give COMI minimal, like it's just going to be like removing a lot of text of the current document, simplifying some stuff, and having 3 base operations, and then having like maybe a second section that does this, or a second document that does the that uses the first.
Yeah, Carsten Bormann. the current document proudly shows all those REST verbs that we have, get and delete and post and put and all that.
Closer to the mic.
Just shows how to use them with Komai. So this is all wonderful, but it's a lot of complexity. I don't know how many media types we are generating there, and it's not really solving a big problem. So maybe this minimal form is a good thing, but maybe another way to look at this is it might make sense to add get as a third method that we want to support, but that's it. So we don't really want to do the other things. If you want to modify something, it's not really a very onerous to do a patch. And only if you just want to get at a single item, maybe supporting get as a third method might make sense. Then we wouldn't have two different versions, two different capability sets, which always is an interoperability.
So I really, yeah, that's something that I really looked at it, and we discussed about it. And the thing is that in get, you have a URI.
Yes.
So if it's simply having a get a SID, so you have a get and you want to get one item that is identified by one SID, it's super easy. There's no problem about this. The question is if you want to do a get on an item that is part of a list.
Well, we have fetch. So if you want to do something complicated, use fetch.
Okay, but then then the problem is that your get is super partial. Like you can only get some items, like a super subset of the thing. So you need to say, okay, part of the things in my Yang module, I can do it, I can get through a get, and parts I cannot. Maybe it could make sense if you want to say, okay, I can only get like the first level of the things. Like if I have a first level element, like if it's a container, I can do a get and I'll get the whole stuff. If it's an item, I can get a leaf, I can get this leaf. But if I want to get like the first item of a container, maybe no, this one I could get also. But if I have a list, then I cannot. I will do a get and I will get the whole list. I cannot say, okay, I want this item of this list.
We probably should go through the examples and see whether there's actually added value for having the get. So I just wanted to throw this into the room that maybe we don't want to do a minimal and an extended, but we want simply do the right thing, and that may be exactly fetch and patch, or it may be fetch and patch plus one more method like get. But let's look through the examples and see what actually makes sense. We don't have to support all of REST just because it's there.
Okay, sounds reasonable. I try to do this to do the exercise to provide how would it look like without the other methods, and if we only have the get method. Sounds. I mean, we have it working even now, so. For us, it's a question of text editing. So that's on Kamai, and now on SID. So SID is the identifiers that are used in Kamai, and here just a short reminder. So SID is simply a 64-bit number that's. Of course, it is a 64-bit, but because it's expressed in CBOR, it can be on 1 byte, 2 bytes, 4 bytes, and so forth. So it's pretty dynamic. It is a file, so you have like a Yang schema that represents a JSON that maps to a JSON or CBOR if you want. And then you have the life cycle of a model, and you have allocation policies. So you have a two-tier allocation policy that you have. The first one is managed by IANA. It's called the mega range registry, and IANA allocates chunks of 1 million SIDs. And then we have a second level registry that people go and can much more actively allocate sub-ranges. So since the last time we have these 3 that are solved, and this one that was somehow we were not clear, is it really solved? Are there any problems? So we discussed again and again with IANA. We discussed also with so many people, and they said, okay, we should not be just keeping the working group last call for this, right? These are things that could be solved when it comes to IANA, and then they'll say, okay, well, there is this detail or this detail that should be a little bit changed, but generally the document is good. So that's that. It's good. We have not changed anything. So right now the next thing is, okay, so what about it? Oh, Peter.
Peter van der Stok, a very simple question. One of the SID generation tool. For the moment, it's difficult to know where it is. Will it be part of the IETF useful tools page? Okay, because that will really help, I think.
Yeah. Yes, thank you, Peter. So that's actually an excellent question. So, so whenever you have a Yang file, you have a tool to generate the SID file, so the correspondence. It's a tool that's like a plugin for Pyang. So it's the super standard thing that people use for Yang, and it's just like a plugin. It is not yet in the main branch, but it has been stable for a long time now. So what we did was basically we made a web interface around it. We wrapped it up, and it works. And since this weekend, so this was like the partial hackathon that we had around several virtual places, we have also set up the SID registry. So this is the first SID registry that is out there. That is in some kind of minimum viable MVP mode, minimum viable product. So we will start operating it a little bit illegally, just to see how it goes, right? In the second million of the SID registry, because for the moment there is no mega range SID registry. IANA has not created this, so we cannot legally obtain like 1 million blocks to start to play with. So what we're going to do is we are going to say, hey, we pretend as if we have this thing. By the time the working group last call passes and IANA goes all through the whole process and the mega range registry is created. But in the meantime, we will get the feeling and people will start using it, and hopefully, it will just get translated. The moment everything is in place, we'll just say, okay, yeah, it's there. So we have this.
Just to put this into context, that's a normal thing to do. When you write a document and create an IANA registry, you provide an initial population of that registry.
Yeah.
So in this case, you would say the 1M to 2M range is taken up by this.
Okay, yeah. So that's the normal thing to do. And so this is the interface. So we have so this is the basic the login page. So this has been existing for like a couple of months now. So you can come and then you can click on login, all this stuff. So you come in, you register. So you fill in some information about yourself, like from which country and so forth. We have a super secure way of actually detecting if you're a computer or not. So we're using reCAPTCHA. And then once you have signed up, you can log in. And then when you have logged in, you can see all the modules that are available on the system. Yeah, there was a question. Yeah.
Yeah, there's a comment by Michael. Just a second. I don't know if it happened. I think it happened a couple of slides before.
Yeah.
But he thinks that the minimum is a select merge format where the select user links attribute values and merge works under. Wait, hold it. I think he's going to make a proposal on the select merge, but I think it was on the previous slide. So sorry. It's just relayed a bit late.
Okay. So
it was a previous discussion. Sorry.
No problem. So you have this welcome page, and here, if you go to, you see, so this answers Peter's question. Here you have the tools. Right away, you have SID file generation, SID file update, and SID file consistency check. So if you click on these links, you don't need to go on to login to this. You just provide your Yang file on a web interface, and then it produces you the SID. So what you need to do is you need to log in, request a SID range. So, for example, you're the 10th user. You go there and use the 10th company, and you'll get the range from 1,010,000 to 1,011,000. So these are your 1,000 SIDs. And then you go here on this file generation, you click and you say, okay, I have these 1,000 SIDs. This is my Yang file. And then the tool produces the SID file that corresponds to it and puts the correct SID files. And then you can go up and upload this SID file to the to the registry, and then it gets fixed and logged in.
This is Matthias for the minutes. So where did you set this up?
Sorry?
Where did you set this up? So I see these nice screenshots, but how do I get there?
Okay, so
127,001. You can see
so
that.
actually, so yeah, so you see, so these are all the nice things here. So you have here when you log in, you have the seed ranges that are there. So your account, the seed ranges that are mapped to different
Yeah, that's there. But how do I get there? Is this linked? From where is it linked, or can I?
So
there. Okay.
there is a small problem here, but I tried it. No, it's not working now. No, it was working yesterday evening. So I think that we had some update problem during the night. You know, people working in some other time zones were updating stuff, and right now it's not working, but it will be working in the next 2 or 3 days. Like we can just go and log in, and you can just go and log in and try it, and. As I said, so these 3 points were actually addressed by what Carsten said. So this is like the first place that we'll be testing the whole thing. The most important thing is also to get feedback on the behavior of how things are behaving. Like people can say, hey, this is really not working for me. I would like you to see the process in this way or in this way. It's not the important part. Like this, we can change this process. The most important part is that we have the registry, that people register their SIDs, and that we have this nice process where we avoid land grabbing, and we fluidify this process. So and we don't overburden IANA with every small module someone can want to register somewhere around the world. So these are the design. These are the design. Constraints that we put to ourselves. So right now the question is, do we do a last call on it, or do we wait more? We would like to see some cross-validation with NetMod, like we started getting all these discussions, but what is the right time to do? What is the right thing to do as a next step?
So at the last IETF, we said the Yang-Zibo document is pretty much ready for working group last call, but we wanted to see an interop. So maybe you can actually continue what you started at this weekend, a couple more days, and write up a little bit of a report about that as a. If I touch anything here, the contacts go away.
Yeah.
And then send a message to the mailing list explaining what you did and what your experiences were. And of course, you should do this in a way that other people who want to participate in that also can do that. So I think that's what we said last time. We want to have that interop, and we are halfway through, I think. Whoops. So that's the Yang-Zibo document. And maybe the Yang-Zibo document also is the first one we actually want to last call, because this is one where we need very close coordination with NetMod and NetConf and so on. So that's something that people really need to look at. The other documents are more core specific. And I think we don't have such a high coordination requirement there, so we can do our normal 2-week working last calls. So we can probably do those a little bit later, and use the time to continue on the interop.
Okay, so I agree. Just on this point, so completely agree with you at this point about the SID. So draft core SID, we actually use a Yang file, so a Yang module, to define the structure of the file, the structure of the SID file. So the way this information is stored for all the SID. So sorry. The way this information is stored is actually described as a Yang file. It's a Yang schema, and moreover, we are basically saying, okay, well, these are some useful things to know about a Yang module. So we have this basic Yang module, and then we have this like correspondence where we say, well, there is this link, there is this URI, and this is the SID that is allocated. So it's some kind of a meta information about the it's a super light meta information about the initial Yang module. So the question is, maybe the guys from NetMod would like to at least take a look at it and say, well, well, I mean, we started talking to them and they said, oh, okay, that's pretty interesting. We'll review it. But just saying that at some point, we may also try to look for their opinion. Okay, I'm going to take this in this way. I think it's better. And so with this, I have finished.
Alex, just a comment.
Yeah.
Michael Richardson is asking if he can use Komai to allocate seat ranges.
To use Komai to allocate seat ranges? That's an excellent idea. I think that I'll invite him on the next interop to come and to code the part into the seat registry code. But yes, that could be really cool. That would be, yeah, it's possible. And so now I'm going to pass the word, but before passing the word to the mic to Hank, Hank is okay. So during this hackathon, there was something really interesting that happened, and that was that people on the next table were really, really busy bringing this new great feature to the world of Yang, that is push. So Yang push that is used for telemetry. And what's really interesting is that this is actually a cross-working group work. So you have SACM, NetConf, and Core that are working on this, and you have a very interesting way to see how you have like a whole process. So basically, for the moment, it's using XMPP. You have a process to see how a collector or something that is observing, like an observer, can go and can discover devices, can see what is happening in real time, can have update streaming events from what's happening from the configuration and operational data. And so this thing, okay, so it won the best cross-working group collaboration work. And what is really important is that for the moment it is using, so there is this new technology that is called Yang Push, and it is based on NetConf and RESTConf for the moment. And right now it's actually the moment to go and go deeper into the Komai world, into the world of IoT, into the world of very efficient telemetry. And Hank and Eric and a couple of other people have actually written, they have written a draft on this. That is the problem statement. And now Hank is going to say in a much better way what it's all about.
Thank you. Yeah, hi, I'm Hank. Next slide. So yeah, Yang Push is built and designed in NetConf workgroup. Leading parties are, for example, co-authors of this problem statement. But there are a lot more people involved in that. It's called the Yang Push design team, eventually written with a Z. I think it's a tradition. So we created a problem statement that basically tried to, is actually effectively identifying gaps in the co-op realm and the Komai realm in order to create a Komai data store that would support the same push operations that are already able to be conducted via NetConf and RESTConf. So the natural order of things would be to now make this happen in Komai. First of all, telemetry means in this context that the data store contains state, and that state is a kind of subscription to changes to configuration operational data. So in essence, if you think back a few tens of years, SNMP traps were doing the same thing. And they're now reached Yang, so to speak, and are facilitated in actual protocols that are NetConf and RESTConf. So the streaming of continuous changes happens on the device without further interaction coming from the client. We have a lot of things to do here. For example, we sometimes want to have a subset of things from the module. We do not want to subscribe to everything, like I don't know, 1,000 leaves in the module. So we have a filter expression in this subscription, which is, for example, differentiating it from the pub sub that is already existing in CoAP. And in the end, it will enable data in motion that is way more self-descriptive than it is now, using standard modules. I think there are about 800 Yang modules already defined in the IETF. And therefore, the principle of not reinventing the wheel is being applied here. Also, using CoAP and the binary representation will, of course, in the future enable a far better scalability. I mean, this is an overused term, but it effectively really will enable a lot of more telemetry on the wire, especially if composite devices start to have their own data stores inside them. So a device might be a set of multiple data stores. So how are we planning to do this? Fetch is not only able to do the observe operation to basically establish an subscription, but also is able to convey a filter expression due to its capability of containing a body. So we are creating media types that will be enabling XPath expression, for example, or, as we just heard, a specific get on a subtree to get everything from that set down. If it's a leaf, it's just one value. It could be a container. So you can also do subtree subscriptions with gets, basically without the filter expression, I think, Eric. So we have to think about this. This was coming up just before my little report here. So we're going to do write at least 2 drafts. I'm not highlighting here that there's something called call home. I'm just mentioning that now. So the data store sometimes wants to find a suitable client that it's supposed to subscribe to it. And this can be triggered by just initiating the TLS or DTLS connection and then say peer allowed to send. And then the roles change. The client then starts a dynamic subscription, for example, and then we go into the realm of onboarding, bootstrapping, and such. So that might be a little bit complicated for today. We're starting with the fetch and get operations with the observe to get the subscriptions on the Komai data store. The important thing here is that Komai is not really well visible in NetConf workgroup. So we are trying to remediate that situation by bringing on more NetConf people, looking into specifically this new draft that will be the subscription to the Komai data store. And our rough educated guess is that it will be about 43.7% experts from Komai and a little bit more experts from NetConf necessary to make this a feasible document and a feasible approach. So I think this is my little report. Yes, it is. And the first question is from Hannes.
Henk, when you say XPath, do you really mean XPath, or is it kind of? Because
Yes, of course.
XPath is a very powerful mechanism, and maybe that's intentional, or maybe I'm not sure in what the functionality really is.
That is very true. So we have the subtree concept, which is basically done by getting a specific SID and everything below it. This is the other alternative that is existing in Yang 1.1, RFC. And Eric has I think, a sophisticated answer to the rest of the XPath question.
Yeah, basically, we intentionally with the Yang push did not limit the XPath elements that can be used. We're leaving that to implementation, and anybody at this point can choose what subset they want to support, because it's very difficult to choose which subsets you want. And we certainly didn't want to do it generically across all kind of technologies. So the standard allows XPath, implementations will choose which things are minimal.
Well, that probably doesn't work. Like from an interoperability point of view, you can't, because it's almost like a scripting language, XPath. So you can't just send it there and then assume, well, but what is the anticipated interoperability then? Like, is there a minimum set that you need to support, and if you provide something else, then you bounce back and say error, reformulate your question, or?
Yes, that's exactly.
Okay.
So I can just finish. The yang push has a RPC mechanism where if something's not supported, it provides back a look and a pointer to what is the current error with or the current non-supported element. So we do have a query response mechanism in the RPCs for the filter.
So let me highlight before the next question comes in that we are targeting two sides of the same coin here. First of all, we are targeting less volume on the wire and more self-descriptiveness of today, basically raw values that are pushed around. So that's supporting unsolicited push of information, and you actually know what's happening, what's pushed to you. This is not IoT. This is just another enhancement and natural progression of how to make better use of your resources. Then, on the other hand, we have constrained devices, and they might not really like the complexity of XPath expressions and answering RPCs all the time. So you can fall back, of course, to the most simple way to do just the subtree subscription. This is to be decided. This will be stuff we have to discuss when we write the draft and progress the draft. And now Eric has a comment.
Yeah. To follow up on the other answer, because this is related, the yang push does allow filters, and we have transport drafts for netconf, HB2, Comite. So it's possible to put for transport what specific filters, what elements you'd want to support. So there's no reason you cannot apply additional constraints by transport if that's the way you choose to do and limit what's there while the overall mechanism's in place. So there are definitely by transport additional technology selections which are allowed as we expand past the base implementation that we used in the hackathon, which was netconf.
True.
So Tim Carey-Nokia, I do have a question as I was trying to figure this out, because, you know, one for telemetry, when we look at, you know, normal nodes, not IoT constrained nodes, I mean, it does a very nice job of giving a general framework for pushing data, right, for telemetry. In an IoT world with constrained devices, you know, originally we had this thing called Observe that kind of did that, right? So I'm trying to understand how we're going to get this. If you ever look at the push framework, it's a rather heavy framework when you compare it to something that's constrained. And so I'm trying to figure out exactly what this means to constrained devices that, you know, Observe was all they really needed, and then what does push really look like in that context? I'm very concerned that, you know, as we start bringing the stuff over from NetMod and NetConf, and we get all the things that go around, you know, more expectations that you would have on routers than you would have on an IoT device, that, you know, this framework wouldn't really work it might work on a constrained network, but it would be difficult to justify in a constrained node. And I'm just trying to understand, you know, what you guys are thinking about in terms of Observe versus push in telemetry.
Oh, sorry. This is touching the topic of call home, or finding a home to call home to. If you're bootstrapping, or if you're drop shipped, or if you're imprinted, or if you're enrolled, at some point you want to send out data as an IoT device. A lot of mechanisms how to bring the things into the field. And this here allows for a very slimmed down, semantic, well-defined output that is interoperable with everything else that's already out there, which is a big benefit. If you have a lot of other devices that are already data stores, a lot of post-processing infrastructure that can handle all that information, it is kind of practical if the things that just appear in your domain and then push information to you can be processed in just like the exactly same way. There is a homogeneity to the complete process that will simplify interoperability drastically. Also, what you are getting at is it has a huge overhead. So, but an IoT device can have some hard-coded, some more. I wish the video could see that.
One other item, there is a parallel structure. You guys might have heard of DDS, Distributed Data Service. The same mechanisms are shown to work on IoT devices there. So there are proof points that if you don't require deep filtering, there are implementations which do similar stuff, except it's not using Yang, it's using, whatever the language is there.
Yeah. So, Carsten Moorman, the underlying question here is Yang good for you? And I think that's a complex question, and not everybody will answer this question with yes. But for those areas where Yang is actually a useful technology to work with, the next question is, can we make that scalable? And scalable not upwards, but as we are always interested, downwards. So can we define a version of this Yang push environment that actually makes sense on a limited device? That is probably not going to be your light switch. It's probably going to be a little bit more powerful device. So I don't think we are targeting class 1 devices here. But still, can we make this work in a way that it's not dominating the actual application that is running on the node, but is available for making these event streams available for telemetry purposes? And right now, I wouldn't say, yes, sure, we're still trying to do that, but I'm pretty optimistic.
Yeah, to add to that comment, that's what the problem statement, which is published, basically highlights at the first section. Most of the building blocks are there, and they're actually quite feasible to build something way more static than the typical data store, if you're required to do so, if you do not have the resources to react in a RPC interactive error detecting way. And now, Hannes.
Henk, I was waiting to hear the answer to Tim's question about how does this relate to the observe mechanism? Is it?
It is using the observe mechanism. That's how it related. It is a fetch observe with the body. It is a filter expression or a subtree, probably.
Okay, because maybe you have an example in the problem statement document, which I then need to look at. But my understanding of the observe was, and some of the other work that was done, there were filters separately defined for observe to do that, and then you use the observe mechanism to send the notifications. But what we heard earlier, or I believe I heard, was you use a different filter expression mechanism, and maybe the answer that you get is also different. So maybe just an example in the slides or in the document would help to help me to understand, because I don't understand it.
Unfortunately, this is bad conduct, I think. The problem statement has a lot of approaches for suggestions to make it better understandable. So it's not only a problem statement, but also a set of proposed solutions, unfortunately, which is bad conduct. We should have done this in 2 documents. But we biased now the problem statement by providing for every solution area a set of proposals how to solve this. And it is already outdated. So we had a few days to talk about this, and we already advanced those. But there are examples in there, yes.
So I asked for this presentation mainly so that the working group has a heads up that this stuff is happening. Again, I don't think we're in a situation yet where we can say, oh, this has been proven to work. It's obvious that we want to go there. There still is a need for additional work, but then it's good for the working group to know that this work is going on, and some people may want to take part in that. So I don't think we are asking the working group to take on this work today.
Yeah, please do not adopt a problem statement.
This is Matthias. I tried to make sense out of this for the minutes. So in the beginning, I saw there's this push framework using XMPP, and you use XPath and so on.
Okay.
And so what I understood is that you said, hey, this overall mechanism could be good also for constrained environments. So you're looking for the equivalent over what Komai does already in this space. Is that kind of a good summary?
Ignore the slide. This has nothing to do with core. The fact is that here's core, and core can be used here, and that's it. Ignore the slide. This slide shows how pushed information can be post-processed in a security automation domain that is SECOM, and can be used to create topology pictures by on-chain subscriptions for neighborhood discovery between devices, and or whatever. If your USB serial connector just was connected and your switch is now manually locally configured, these are change events in operational state that can be pushed to a SECOM collector and then be further distributed in security automation domain that is able to detect anomalies, does machine learning or something else. So this is basically a application of Yang push. And we want this to be far broader than a netconf and restconf only. We see a lot of applications that are already trying to create multiple data stores per device. And the number of telemetry streams will increase drastically if this trend continues. So please ignore the slide in the context of CoApp. It's CoApp starts here. These are just the results from Hackathon.
Okay, but you're still looking for something that kind of fits the overall ecosystem, using Yang, using the push mechanism and so on, but you're looking for this blue part that was at the bottom going to the devices. It should use kind of the same, how you model data, how you transmit it, but
Yes.
you're using for a good transport that uses CoApp with CoApp Observe and some optimized filters and not the XPath and heavyweight stuff.
We are still unsure how to deal with the very complicated XPath stuff. I think there have to be compromises. This is the most interesting thing that's not been discussed yet. It's about the media type definitions we have to do. But in general, you're correct. The fact is there's so many Yang modules out there. And most of them are actually kind of useful. I mean, despite the 800 done by IETF, there are about, I think, 2,000 done in total by the industry. So there's a lot of good stuff out there. And not making use of that is kind of redundant and probably not the best idea. So that's one of the drivers for using Yang again. I know people are kind of fed up with that term at some point, I know. And some other SDOs use something else entirely, which is not necessarily better, but they use other ways to express the models. And this is just another way to ensure long-lasting interoperability and reducing redundancy in defining models for data that has been transported for years already. And now I'm done. Again, I'm waved from the square.
Thank you. So as I predicted, Komai has managed to squander our time advantage completely. And we will move the PubSub part to Tuesday. So we have a chance to get Adrian, who is only here today, to quickly talk about payment over CoApp.
And thank you for all the questions and input.
So this was a last-minute decision to come to this session based on interactions I had last week at W3C TPAC with Web of Things working group and some people there. So I chair the payments working group at W3C, and there's a number of APIs rolling into browsers today for payments. The way they work is that the website constructs a payment request, which it submits to the API, and in that request is a set of accepted payment methods. So the API itself and the data model is quite generic, and you could put anything in there. What has emerged is a desire from part of that working group as well as the Web of Things working group to look for ways to bind that same data model to alternative transport. So not a browser API, but the initial proposal was HTTP. The people I spoke with in San Francisco were interested in exploring if COAP bindings would also be worth digging into. So the expected interaction would be something makes a request, and instead of getting a response to that request, it gets a request to pay. The payment's made some other way, and then the request is retried. So it's likely the work will continue within a W3C group for some time, but making you aware of it in case you're interested in getting involved. W3C have created a mailing list, so if you are interested, just join that public IoT pay list, and the work will probably get moving in the next few weeks. And that's it.
Yeah, so if you look at the way this payment required stuff works, that is really reminiscent of the way ACE handles the case where you access a resource server and are not authorized to do it yet. Probably the right group to present this in would have been the ACE group, but that is only happening tomorrow, and Adrian is here today.
Sorry about that.
I think that's a useful thing to keep in mind. There is a payment infrastructure being defined, and that will need some ways to reach down to constrained devices. And my personal example is always a coffee maker. I want to be able to instruct the coffee maker to make a coffee for me. But if that coffee maker requires payment, how do I do this with CoAP today? And so probably the ACE framework is actually already quite useful for doing that. So it probably makes sense to bring these things together in some form, and it may be interesting to look at Adrian's work.
So the way the data model works is it's quite possible that the response can be very static. So your coffee maker could be pre-configured or have a very static. So it could work very well in a very constrained device as well. It doesn't need to do any payment processing itself. It would need to be able to do something like produce the payment request information, which could be very static, and then validate maybe a token later that proves payment happened somewhere else. So I think the model would be applicable in constrained space, in constrained devices, but leave that to the experts, out of my wheelhouse a little bit.
This is Hannes. I just opened the document, scanned through it, but it doesn't. It sounds like related to the ACE framework, but it doesn't actually use the ACE framework. It doesn't use access token. It doesn't use OAuth, at least from a quick glance. So you seem to be defining something that is somewhat similar, but with your own header format and everything else.
Maybe ACE is the right way to do it in CoAP. Like I say, I'm outside of my wheelhouse in the CoAP sort of world, so I would invite participation from anyone who's interested in this. Yeah.
Eric Scorla, what are you assuming the client for this activity is?
What am I assuming the client to be?
Yes.
No assumption.
Well, it is a web payment working group you are chairing. So
today, the current API binding is defined for browsers of the client, but the data model makes no assumption. The data model simply says, give me a set of payment methods that you support.
No, I'm familiar with how the web payments API works, but my question is, like, what set of interactions between the device and the client depends on what you say the capabilities of the client are. If you say the capabilities of the client are basically generic web browser, then one sort of idiom is appropriate. And if you assume it is something which is going to have a standardized protocol, another sort of idiom is appropriate.
Sure.
And so, given that the interaction from the web browser punts this problem by basically making a JavaScript API and having stuff behind the covers. And so if you're, given that the actual payment operation here is a miracle occurs behind the scenes, it's important to understand what you think the capabilities of that device are.
of the client making the
Yes.
request and subsequently initiating the payment.
Yes.
I think it's very determined by the payment methods that are used. So some payment methods could be an exchange of tokens that are understood to be valid for a prepaid arrangement. That could be perfectly valid. Or it can be much more sophisticated that the client actually has to go online to a payment service and execute a payment. The purpose here is to try and decouple those two things.
No, I'm not asking the question of what the payment mechanism is. I'm asking the question if we think the device is that is doing this work.
I'm failing to see why that's relevant.
Because the capabilities of that device dictate what kind of API or interaction mechanism is appropriate.
Again, if the device is not capable of doing a sophisticated payment method, then it would not be able to interact with a server that requests that payment method. It's an agreement between the two devices of payment methods that they can both do. So
You're misunderstanding me, but I don't think it's worth doing right now.
Clearly I am.
Yeah, I don't really think it's worth it right now. Thank you.
Okay, thank you, Adrian. So we are at the end of our allotted time. So we will meet again tomorrow at 1:30.